before we get into some examples, I want to talk about a problem-solving strategy for dealing with these types of problems, and most types of physics problems that we're going to come across. First of all, underline or highlight important information as you read the question. Draw the situation with important information and draw a dotted circle around the system. The system is just the part of the situation that you care about. Use the particle model if appropriate. Write out given important information and the variables. Ask yourself, what do I need to find first? Substitute and solve. And then finally, ask yourself, does the answer make sense with units? Here's our example. Each block represents 1 square meter. An object moves from point A to point B to point C, then to point D as shown in the figure below. Find the distance covered by the moving object and find the magnitude and direction of the displacement of the object. So first we're going to cover the distance. Picture's drawn for us, so we don't need to figure this out. We can just start solving this problem. From A to B is down 2 and right 1. We can use Pythagorean theorem to see this is about 2.24 meters. From B to C, the distance is 4 meters. From C to D, this is a diagonal line, so we can break that diagonal line into pieces or components, add up those two pieces using Pythagorean theorem again. We see that we get c squared equals 7 squared plus 5 squared, which is approximately 8.06 meters. This means the total distance is the first bit, then the 4 meters, and then the 8.06 meters to give us 14.3 meters as our total distance. Next, find the magnitude and the displacement of the object. Remember, displacement is the distance, including direction, from the ending point to the starting point. We end at coordinate -4, 2, and we started at 1, 3. One way to solve this is to draw a right triangle and use Pythagorean theorem again. C squared equals 5 squared plus 1 squared, which gives us about 5.1 meters. We know that, back to that before we move on. We know that the direction is positive because it's moving up and to the right, and both of those are positive, so we can just leave it as 5.1 meters. We can say the displacement is 5.1 meters south of west, because our ending point is south and west of where we started. Next steps. Complete practice problems as prescribed on the website. For more practice, use the AI prompt. Provide me with 3 practice problems for calculating average distance, speed, displacement, and velocity. Make the difficulty on par with a honors high school physics class. You can change that to AP level. You can change it to college level, whatever you feel like you want. Or if you want to make it a little bit easier, make it a standard high school physics class. Show me the answer, no solution. That's it. So don't forget to ask each other for help with issues that pop up. Ask me, keep asking until you get it. That's it.